Hello and welcome to my class. My name is Teacher Foster. Today we are looking at a lesson on sets. Alright, now there are certain numbers which can be expressed as a ratio of the other. Let's say in the form A over B, where B is not equal to 0. Numbers which can be expressed in this form, we refer to them as rational numbers. So for example, 2 is a rational number because I can write this as 2 over 1. I can say that 1 whole number 1 over 4. When I convert this, it should give me 5 over 4. So numbers that can be expressed in this form are what we refer to as rational numbers. However, there are some numbers that cannot be expressed in the form A over B. And such numbers, we refer to them as irrational numbers. Now, when we talk about sets, we are saying that when we find the square root of numbers which are not perfect square, in other words, numbers that we cannot get an exact value, then we say that that is a set. Don't forget that the square root of the number must be a rational number. So for instance, root 2, root 3. These numbers are rational numbers. So when I find the square root of rational numbers which are not perfect square, we refer to that as a set. Alright. However, please take note that the square root of negative numbers will not exist. And so I cannot find the square root of, let's say, negative 2. This does not exist. So when we talk about set, we are basically saying that we are finding the square root of rational numbers that are not perfect squares. So that's what we mean by set. So there are certain rules that govern the concept of set. So let us look straight into the rules of. Alright, so let's look at some rules governing the concept of set. One, we are saying that root A times root A is root A squared, which is equal to A. What it means is that, for example, if I have the root of the same number multiplying, then my answer should be the number. So let's look at this. Root 2 times root 2. This 2 is multiplying 2, which is giving me 4. And because 4 is a perfect square, when I find the square root of 4, it gives me 2. So it means that when I'm multiplying two sets and the numbers are the same, then my answer is the number. So that's why I say that root A times root A should give me A. Second example, A times root B is equal to A root B. So if I have a number, let's say 3 multiplying root 2, this will now give me 3 root 2. Alright, let's also look at this. Root A times root B. Here the numbers are different. So the numbers will multiply under the root. So for instance, if I have root 4, let me use root 3 times root 5. This is the same as root of 3 times 5. That will be root 15. Alright. Now, let's look at another root. A root B multiplying C root D. The numbers in front of the root will multiply, as well as the numbers under the root. They are also different. So if I have 3 root 2 multiplying 4 root 3, the numbers in. Alright, so when I'm multiplying these two sets, the numbers in front will multiply, as well as the number under the root. They are different, so they also multiply. So this times this, that should give me 3 times 4. Then the numbers under the root will also multiply, which is 2 times 3. So this will give me 12 root 6. Alright, now let's come to the last one. Root A over root B. We are saying that it's the same as square root of A over B. So for example, if I'm finding root 2 over root 3, this is the same as square root of 2 over 3. So these are the rules that we'll be using in solving questions in under sets and apply them to some concept of set. So these are the rules. Root A times root A gives us A times root B is giving us A root B. Root A times root B is giving us root AB. A root B multiplying C root D is AC root BD. And root A over root B is giving us square root of A over B. So these are the rules of set. Now let's just look at how we can simplify set. Alright, so we are looking at how we can simplify sets. We are looking at addition and subtraction of sets. Now we are saying that for you to be able to add two sets, the numbers under the root must be the same. That is the condition for adding or subtracting two sets. So if you look at our example, I see that p root a plus q root a is equal to p plus q root a. Now what happens is that we add the numbers in front of the roots. So for example, if I want to add, let's say 3 root 2 and 4 root 2. Now because the numbers under the roots are the same, they are like terms. The group expression is the same thing. Since the numbers under the roots are the same, then I can add the numbers in front of the set. So this will be 3 plus 4, then root 2, which is common. Then I would 3 plus 4 should give me 7, so this will be 7 root 2. So that is addition of sets. Take note that root 3 plus root 2 is not equal to root 5. This is not equal to root 5 because the numbers under the set are not the same, and so we cannot add them. Please take note. The same thing applies to subtraction. We are saying that the numbers under the root must be the same before we can subtract. So for instance, 7 root 3 minus 5 root 3. Yes, I can subtract this because the numbers under the roots are the same. So I'll subtract the numbers in front. That should give me 7 minus 5 root 3. And this should give me 2 root 3. So that is the subtraction of set. Again, take note that root 7 minus root 5 is not equal to root 2. It is not equal to root 2. Please take note, because the numbers under the set are not the same. Alright, we say that a set of the form a root b is simplified if the number under the root does not contain a perfect square. So this can only be simplified if the number, which is b, does not contain a perfect square. For instance, root 2 is simplified. If I have root 5, it's simplified. If I have root 10, it's simplified. But root 12 is not simplified because root 12 contains a factor which is a perfect square. So I'll now write my root 12 as 4 times 3. This is a perfect square. The square root of 4 is 2, and that should give me 2 root 3. So when I simplify root 12, that should give me 2 root 3. So please let us take note. So anytime you want to add two sets, the numbers under the root must be the same. Same way for subtraction. When you want to subtract two sets, the numbers under the root must be the same. Take note. And we are saying that once you can find a perfect square in a number under the root, the number is not simplified. It becomes simplified when you cannot find a factor which is a perfect square, like what we have here. If I take root 15, I write this as 3 times 5. It does not contain any number which is a perfect square. Another way I can write root 15 is probably 1 times 15. Root 45. Let's look at this. Root 45 is not simplified because I can find a perfect square from this. So look at it. I can write my root 45 as 9 times. I write my root 45 as 5 as 9 times 5. 9 is a perfect square. So that will give me 3 root 5. And this becomes simplified. So this is how we simplify sets. We add and subtract sets. Please take note that the numbers under the root must be the same. Alright, let's look at how we multiply sets. Alright, in multiplication of sets, unlike addition, when we are multiplying sets, we multiply the numbers in front of the root as well as the numbers under the root. So if I have s with n multiplying t with n, that should give me s times t root of n times n. So let's take an example. If I have 3 root 5 multiplying, let's say 4 root 3, I have to multiply the numbers in front. That is 3 times 4. I also multiply the numbers under the root, which is 5 times 3. So this will give me 12, and this will give me 15. So this gives me 12 and 15. So unlike multiplication, unlike addition and subtraction, where the numbers under the root have to be the same before we can add or subtract. When it comes to multiplication, the numbers must not necessarily be the same. It can be the same, but it must not necessarily be the same. We can still multiply. We multiply the numbers in front of the root as well as the numbers under the root. So that is how we multiply sets.